Hi everyone, this tutorial is an introduction to the unit circle. We're going to be looking at both the angles in the unit circle between 0 degrees and 360 degrees and also the trig ratios involved with these angles. This tutorial is part 1 of the unit circle. So what's the unit circle? The unit circle looks like this. As you can see, it's a perfect circle and it's given the name the unit circle because the radius of this circle is always equal to 1 unit. So we have this distance here from the centre of the circle out to the circumference equal to 1 unit. This is the same as this distance here, this distance here, and this distance here. And if I drew a line from this centre point here out to the circumference of the circle, this distance here would also be 1 unit. The unit circle is comprised of 4 quadrants, and when we're looking at the quadrants, we always move around the unit circle in an anti-clockwise direction. So we move this way. This means that this quadrant here is the first quadrant, this quadrant here is the second quadrant, the third quadrant, and the fourth quadrant. When we look at the unit circle and we know that it's divided into these 4 quadrants, we can see that the angles in the unit circle between each of these quadrants are 0 degrees here, going anti-clockwise through to 90 degrees, through to 180 degrees, through to 270 degrees, and then back to where we started from, but because we've done 1 revolution of the unit circle, we are now at 360 degrees. So in the first quadrant, we're always dealing with the angles between 0 degrees and 90 degrees. In the second quadrant, the angles between 90 and 180. The third, the angles between 180 and 270, and the fourth, the angles between 270 and 360. As well as looking at the angles in the unit circle, the angles in these 4 quadrants, we can also look at the unit circle in a different way. These lines here, which divide the unit circle into its 4 quadrants, can also be viewed almost as a Cartesian plane which has been drawn on the unit circle. So we look at this and read it as an x-axis and this line here as a y-axis. Now, if the unit circle has a radius of 1 unit, and we know that this distance from the centre of the circle out to the circumference of the circle here as 1 unit, we view this line here as the positive side of the x-axis. So this point here will have the coordinates 1, 0. In the same way, when we look at this vertical line here, we view it as the positive side of the y-axis. So this point here on the circumference of the unit circle has the coordinates 0, 1. We look at the horizontal line again, coming out to 180 degrees, and again, this time we view this line as the negative side of the x-axis. This means that this point here will have the coordinates negative 1, 0. And finally, this line here is seen as the negative side of the y-axis. So this point down here has the coordinates 0, negative 1. I want to first of all look at the angles in the first quadrant of the unit circle. If I start here at 0 degrees on the unit circle and I start to move through the unit circle and stop here at this point here, I now have an angle at the centre of the circle, and the ray which I have been moving to this point on the unit circle, which I know is 1 unit in length, this ray here and this horizontal line and this vertical line form a right angled triangle. We can see that this angle here is 90 degrees, and we have a vertical side to our triangle and a horizontal side to our triangle. My one unit here is the hypotenuse. This is where our trig ratios come in, and particularly we can focus on sine and cosine. We know that the ratio for sine of any angle in the right angled triangle is the opposite side divided by the hypotenuse. This means that for this angle here, I know that sine of this angle is equal to this vertical distance divided by 1. This, in summary, means that this vertical distance here will also always be equal to sine of this angle at the centre of the circle. So we need to think of this distance here as sine of this angle here. We can look at cosine in the same way. We know that cosine of any angle in the unit circle is equal to the adjacent side over the hypotenuse. Now in this case, cosine of this angle here is equal to the adjacent side divided by 1. This means that this adjacent side here in my right angled triangle will always be equal to cosine of this angle. So this means that this right angled triangle uses some very important trig ratios. We know that as we move through the unit circle and we look at any angle in the first quadrant, that sine of the angle at the centre of the circle will be equal to this vertical distance here, and cosine of this angle at the centre of the circle will equal this distance here. So what I can do is I can label my right angled triangle this way. So I can label this side here as sine of the angle at the centre of the circle. And I'm going to be labelling it as sine theta. This side here I'm going to label as cos of theta, remembering that theta is always equal to the angle at the centre of the circle. Once I've labelled the triangle in this way, it means that I can now look at tan of this angle at the centre of the circle as well. As we know, tan is always equal to the opposite side divided by the adjacent side. If we look at this triangle in general and we take tan of this angle here, we can see that this side opposite this angle is equal to sine of the angle. And the side which is adjacent to this angle is also equal to cos of the angle. This means the tangent of this angle here will be equal to the opposite side divided by the adjacent side. And this means that tan of this angle will equal sine of the angle divided by cosine of the angle. This is one of the first very basic trig identities that we use. An identity is a truth, something that always holds for every situation. And this first identity is known as the tangent identity. And what it says is that tan of any angle will be equal to sine of the angle divided by cos of the angle. So tan of any angle will equal sine of that angle divided by cosine of that angle. You can try this out on your CAS calculator. Pick any angle between 0 and 90 degrees and find tan of that angle. Say you'd find tan of 55 degrees. Now find sine of 55 degrees and cosine of 55 degrees. Divide sine by cos. You should find that you get exactly the same answer as you got for tan of that angle. So in summary, tan of any angle is equal to sine of the angle divided by cosine of the angle. Tan of the angle at the centre of the circle can also be viewed in another way. What we do is we draw a tangent to the unit circle here so that it touches the unit circle at 0 degrees at this point. For definition, a tangent is any straight line which touches a curve at one point and one point only. In this case, the curve is the unit circle, and the tangent is drawn in such a way so that it approaches the circle but only touches it at this point and then continues on away from the unit circle. So we have a tangent drawn to the unit circle at 0 degrees. Once again, I have this angle at the centre of the circle. Now, in our previous example, when we were looking at sine and cos, we took this angle here and we focused on the right angle triangle formed and found that sine of the angle was this vertical distance on the right angle triangle and cosine was the horizontal distance on this right angle triangle. In this case, however, what we do is we take the angle like so, and instead of stopping at this point and drawing a right angle triangle down here, what we do is we extend the line out further from the unit circle and keep extending it until it touches the tangent at this point here. Once the angle touches the tangent here, it's this distance down here, this distance, which tells us tan of that angle at the centre of the circle. Over here I have another example where the angle is in the second quadrant. We can see that this angle is an obtuse angle, in other words greater than 90 degrees, but when I find tan of this angle, instead of extending the line out beyond the unit circle this way, what I'm going to do is I'm going to extend it back through the unit circle until it touches the circumference and then extends out and touches the tangent down here. So tan of this angle will be equal to this distance here along the tangent formed by the angle at the centre of the circle. So tan of the angle is found by looking at the distance along the tangent to the circle that the angle covers when it's at the centre of the circle.